Okay, this is a lesson on solving system of equations by graphing. We're going to learn, I know you don't know what system of equations are yet, but we're going to learn 3 different methods for solving them. Before we do that, I want to review graphing linear equations. It's an essential skill here. So we're going to start by graphing the linear equation 3x minus 4y equals negative 12. You might look at that and recall that you could graph that by graphing the x and y intercepts and drawing a line through those intercepts. But because we're going to sometimes need to be able to see multiple points, we're going to need to know our slope. So I'm going to want you to use slope-intercept to graph these. So we're going to want to convert our equation to this form, as you recall, where m is my slope and b is my y-intercept, where the line goes through the y-axis. I know it's been a while since we've done this. So I'm going to start by getting the negative 4y. I want to get this by itself. So I'm going to subtract 3x from both sides. Sorry, I just thought that looks a little tough to read. So we're going to subtract 3x from both sides, and that will get me that negative 4y. I'm going to put the negative 3x first, minus 12. And then I'm going to multiply both sides by the reciprocal of negative 4, which is negative 1/4. And then I got to distribute that to both terms on the right side. So that'll be y equals 3/4 x plus 3. That's after I distribute that negative 1/4 to both terms there. Now I'm going to graph this my y-intercept here is going to be, remember my y-intercept is going to be this 0, 3 right here. So I'm going to, 0, 3, that's the first thing I'm going to graph, my y-intercept, which is 0, 3, because when x equals 0, y equals 3 in that equation. And my slope is 3/4, and that's my rise over run, my vertical change to horizontal change ratio. So I'm going to go 0, 3, which is right here. And then I'm going to go up 3, 1, 2, 3, and over 1, 2, 3, 4. And I'm actually going to do that more than once. So then I'm going to go up 3 and over 4 again. And then I'm going to put a line through that. So there's my line, put arrows on the end. Now one thing I want to really stress here, because this will be important as we consider what our solution to a system of equation is that each point on the line is considered to be a solution to the equation I start with. So what that means is, so for example, the points that I've identified on the line right now, and every other point that I haven't identified, are these points. So, and every one of these points is a solution to the equation. That means when I plug in for the x and the y, it makes it true. So for example, if I pick the point 8, 9, and it would work for these 2 points as well, it should make the equation true. So let's just verify that. So 3 times 8 minus 4 times 9 should equal negative 12, and that's 24 minus 36. And that does equal negative 12, so, because you get negative 12 equals negative 12. So, and that every other point on the line should make the equation true, therefore it's a solution. So that's an important point going forward. So let's slide this up here. Now let's talk about what a system of equation is. A system of equation, really what I mean here, because we're going to be working with linear equations, it's a system of linear equations. It's a set of 2 or more linear equations that we deal with at the same time. So this is an example of a linear equation. We're not looking at these two equations separately. We're trying to determine something considering them together. So, but I am going to graph them separately, and then we'll make some sort of determination. So let's start with 2x plus 2y equals 4. So if I subtract 2x, I'm trying to get this in slope-intercept form again. And I'll say, give me 2y equals negative 2x plus 4. And then I'm going to multiply by 1/2 on each side. To get the y by itself, multiply by 1/2, and I'll get that y equals 1/2 times negative 2 is negative 1, so that's negative, let's put a negative sign there, negative x, and then 1/2 of 4 is 2. So here my y-intercept is 0, 2, and my slope is negative 1, which we can think of as like negative 1 over 1 or negative 2 over 2. So let's let me go ahead and graph that line. So that's so my y-intercept is 0, negative 2, right there. And then I'm going to go down 1 over 1, because my slope here is, I can think of for a rise over run, I can go that. Down 1 over 1, I can do that many times as I need to, so I can just have plenty of points to draw my line with. Draw a nice straight line. So let me put my line in now. So there it is. Whoops, moved it. Didn't mean to move it. I'm just trying to. Okay, so there's my line, and put arrows on the end. And now let me graph the other equation. Just kind of change the color so it doesn't all meld together. So x plus 3y equals 10. So I'm going to get the y by itself, so I'm going to subtract x. And then I'll have 3y equals negative x plus 10. Okay, so then I'm going to multiply both sides by 1/3 to get the y by itself. And I'll have y equals negative 1/3 x plus 10/3. All right, so let's go back up here and graph this. So my y-intercept is at 3 1/3, so 0, 3 1/3. I could leave that as 10/3 if I wanted to, and my slope is equal to negative 1/3, which we can write as negative 1 over 3. All right, so 0, 3 1/3 is going to be right about here. It's a little high. All right, so that's right about there, and I'm going to go down 1 and over, down 1 and right 3. So that's going to be, that will be right about, so down 1 and over 3 will be right about, down 1 over 3 will be right about here. And I'm going to draw my line now. So there's the graph of that line. Now, what I'd want you to note here is that these two lines actually intersect at the point -2, 4. Now that is actually the what we call the solution to the system of equations, because it's the one point that they share in common. Remember, all the points on both lines, all the points on this line will be solutions to this equation, and all the points on this line will be solutions to this equation, but the one they have in common is -2, 4. And I'll show you that real quickly. If I plug in -2 for x and 4 for y, it'll make both true. Let me try the first equation. 2 times -2 plus 2 times two times 4. Don't need those. Those parentheses. And does that equal 4? That's -4 plus 8, so that's 4 equals 4. And then when I try with the other one, I try -2, just substitute that right in for the x, and then 3 times 4. Does that equal 10? It's -2 plus 12, so 10 equals 10. So you can see that works. So -2, 4 is my solution to that system of equation, and that's what we're looking for with all of these. That we know what we're trying to accomplish. So I'm going to solve this system by graphing. I think I'm going to try to make it just a little bit bigger, so make our job of graphing a little bit easier. So I've got 3x plus y equals 7, and so I am going to look at 3x plus y equals 7, and I'm going to subtract 3x from both sides, and that'll be y equals -3x plus 7. So my y-intercept is 0, 7, and I've got a slope of -3/1. Let me go ahead and graph that. So 3, 6, 7 is right there. And then I go down 3 and right 1. May do that a couple of times just to make the graphing a little easier. Now I'll draw my line. There it is. There's that first line. Well, let's work with the other line. 2x minus y equals -2. Let's subtract 2x from both sides, and that will give me -y equals -2x minus 2. I'm going to multiply both sides by the reciprocal of -1, which is -1. So multiply by -1 to get rid of that negative. Do that on the other side as well, and that will get me y equals, that's just going to change the sign of everything, 2x plus 2. So got a y-intercept of 0, 2, and a slope of 2, or 2/1. So let's graph that one now. So 0, 2 is right here. Clean that up a little bit. And then I'm going to go up 2/1, and actually I've kind of already hit on my intersection point, but just to get more points from my line, up 2/1. And I'm going to draw my line now. So there it is, and I can already see what my point of intersection is. It looks like it's right there at the point 1, 4. Let's notice that. That's at that point 1, 4. Sometimes what I do is I just do like so, but clearly identify your point of intersection there is 1, 4. Let's just kind of talk through it so we don't take too much time. 3 times 1, if x is 1, that's 3, plus 4 is 7, and 2 times, and then over here, 2 times 1 is 2, minus, if y is 4, that would get -2, so it works. Okay, here we go on this next one. I have the system I'm going to solve by graphing. Move this over just a little bit, shrink it up. Solve by graphing x plus y equals 2, and the other equation of the system is x minus y equals 4. So I'm going to take the first equation, convert it to slope-intercept. So I'm going to subtract x from both sides, and I have y equals negative x plus 2. So that means my y-intercept is 0, 2. My slope is negative 1, which we can call negative 1 over 1. My other equation is x minus y equals 4. I'm going to subtract x from both sides. Clean that up a little bit. Going to subtract x from both sides. I have negative y equals negative x plus 4. Got to get rid of that negative, so multiply by the reciprocal of negative 1, which is also negative 1. So I have y equals positive x minus 4. So my y-intercept is 0, negative 4. And now I have a slope of positive 1 on this, which we'll write as 1 over 1. So let me graph this equation over here first. So let's go to the point 0, 2. It's right there. And I'm going to go down 1, right 1, many times as I want to. So that's there, 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 there. Draw my line. So there's that line. Now draw my other line, which I have the y-intercept of 0, negative 4, which is right there. And I'm going to go up 1 over 1, up 1 over 1, and you can see where these actually, sometimes you can see right where they're going to meet. They're going to meet right there. I can draw a couple more points just to get to help with drawing my line. I'll draw my line. That line in, and you can see we have this very nice intersection point right here of that point right there is the point 1, 2, 3, 3, negative 1 is the point of intersection. Let's see if that works in both of our equations, and we'll know it's right. So if I make x3 plus negative 1 is 2, and 3 minus negative 1 means 3 plus 1 or 4, so that works as well.